All right, so let's talk about special right triangles. Okay. The first thing we're going to talk about is what we call 45, 45, 90 triangles. Okay, and this is how you're going to come to know them, as a 45, 45, 90, and so on and so forth. Okay, so how do we create a 45, 45, 90 triangle? Look at what you have here. This is a square, okay, and each side of the square has a length of 1. All right? Yes? Okay. Look at the diagonal. We know that in the case of a square, the diagonals bisect each of the angles, right? So that means that this angle is 45 and this angle is 45. Okay? Now, let's find the length of that diagonal x. Well, we're going to do the Pythagorean theorem, right? So 1 squared plus 1 squared is equal to x squared. Okay? So 1 plus 1, 2 is equal to x squared. Take a square root. X is equal to root 2. Okay? Fine. Now, okay, that's kind of cute. Let's take another square. Okay? This time, I'm going to make each of the sides 3. Why? I don't know, just because. Take a look at the diagonal. Okay? Again, this is a 90-degree angle, and each of these are 45, right? So take a look at what we had here. We had a triangle with one angle that's 90 degrees and 2 45, right? 45, 45, 90. Here too, I have a triangle. 45, 45, 90 are the angles inside. Okay, so that side is 3, that side is 3. Let's find x. 3 squared plus 3 squared is equal to x squared, right? So what do you have now? 18 is equal to x squared. And when you take a square root, what do you get? X is equal to root 18. Okay, so 18 is what perfect square times what? Is 9 times 2, right? So x is equal to 3 root 2. All right? Yeah.
Since 45, 45, 90 triangles have 2 of the same angles, wouldn't the legs both be the same length?
They are.
And if they're the same length, wouldn't that mean that you could just make it a lot easier on yourself and just take the number that's the length of the leg and just put that in front of root 2?
Right, but where does that come from? We're deriving it. Okay? So what do you see here? So the relationship that you see here is, in this case, the legs were both a length of 1, and this hypotenuse is 1 times root 2. In this case, the legs were each a length of 3, and the hypotenuse turned out to be 3 times root 2, right? So that tells us that there is a relationship between the legs and the hypotenuse of a 45, 45, 90 triangle. And that's a theorem, that in a 45, 45, 90 triangle, the length of the hypotenuse is root 2 times the length of the leg. So any time you've got a 45, 45, 90 triangle, the legs have got to be congruent to each other because it's an isosceles triangle, and the hypotenuse is always root 2 times the leg. Okay, so this you have to memorize. Like, you have to memorize it. Of course, you're going to put it on a flashcard. But you know what? You have to commit this to memory. The sooner, the better. So the hypotenuse is equal to the leg times root 2. Okay? Now, in that case, so if you have that relationship, how much is the leg equal to? What do you think? How would you solve this for the leg? It would be the hypotenuse, divided by, so I'm solving for the leg, the hypotenuse divided by root 2. Okay? So memorize one of these, and then you can derive the other one always. Okay? All right, so let's take a look at some of these, and let's solve for x and y. Okay, you can only do this if it's an isosceles right triangle. So you have to know either that, this is 90 degrees and one of the angles is 45, or you have to be told that two of the legs are the same. Okay, so how much is x here? 5, and y? 5 root 2. Because it's a isosceles triangle, it's a 45, 45, 90. And the hypotenuse is the leg times root 2. Okay. So take a look at this one. You have a 45-degree angle, so these are all 45 degrees. Since in this triangle here you have a 45, 45, 90, you know that these two are the same. Okay. So what am I given here? I'm given the hypotenuse, right? So I know that the hypotenuse, is leg times root 2. Okay, this is the leg. What do we know about the size of the leg? It's the hypotenuse divided by 2. 20. So x is going to be, if I can write, 20 over root 2. And we're going to rationalize. So this is 20 root 2 over 2. What I need you to know is root 2 times root 2 is always 2. And now the 20 and the 2 cancel. So x is 10 root 2. Okay. So these are 10 root 2 and 10 root 2. Okay? X and y are congruent here. Yeah.
Why are x and y congruent?
So this is an isosceles triangle. Remember what an isosceles triangle is. If the two base angles are the same, that means the two legs are the same. Right? And that's the isosceles triangle theorem. If if two angles are the same, then the two legs are the same. Okay. So that much about what is this? 45, 45, 90. Okay? Let's talk about 30, 60, 90 triangles. Okay? All right. So for a 30, 60, 90 triangle, there is a similar relationship. To derive it, we start with an equilateral triangle. We know when you have an equilateral triangle, each of the angles are 60 degrees, right? So what we're going to do, this is how we derive it. We're going to draw a perpendicular bisector here. Okay? So that splits the triangle into two. So now these are each congruent and they are 30 degrees. So let's focus on this triangle to the right. If this entire side was 2, then I know that this has a length of 1. Okay? And look at the triangle that I've created here. It's a right triangle. The angles are 30, 60, and 90. Right? Now that's the other special one. So take a look at what we have here. I have one leg and another leg. Do the legs have the same size in this case? No. I have a short leg and a long leg, right? Okay. So I know that this has a length of 1 because it's half of the side of the original triangle. So let's find x using the Pythagorean Theorem. X squared plus 1 squared is equal to 2 squared. X squared is equal to 3. So x is root 3. I took a square root of both sides. Here. Okay? So x plus 1 equals 4, and I subtracted 1. Okay.
Oh.
Okay, so x squared plus 1 squared equals 2 squared. So x squared plus 1 equals 4. X squared equals 3, and then you take a square root. So that's root 3. Okay, so, and of course, if we had a different if we had a different equilateral triangle with, sides of 5, you would get the same relationship, which is, I have a short leg, okay? There is a longer leg, and there's a hypotenuse. Okay, whatever the short leg is, the longer leg is that times root 3. The hypotenuse is the short leg times 2. So we have to go with, in reference to the short leg every single time. So let's say that again. In a 30, 60, 90 triangle, the hypotenuse is twice the shorter leg. The longer leg is root 3 times the shorter leg. Okay, so it all goes in reference to that shorter leg. Okay, now, here we go. This is what I want you to memorize. Hypotenuse is 2 times the shorter leg. The longer leg is root 3 times the shorter leg. Now, how do we figure out long leg, short leg? This is the 90-degree angle. It faces the hypotenuse. Okay? The 30-degree angle faces the shorter leg. The 60-degree angle faces the longer leg. Okay? Questions? You guys look so tired today. Yeah. I know. Okay, so let's do these. Look at what you have. You have a 30, 60, 90. Immediately, where's the short leg here? Tell me. The 10, the x, or the y? The 10. So this is the short leg, this is the long leg, and this is the hypotenuse. Okay? So, here we go. Whatever the short leg is, the long leg is that times root 3. So this is 10 root 3. Okay? Whatever the short leg is, the hypotenuse is 2 times that. So you have to go with these. So that's 20. Okay? Questions? Okay. Let's do another one. X and Y. Okay. So take a look here. Okay. So you have a 60-degree angle here, a 90-degree angle. How big is this angle here? 30. Okay, that means in this triangle to the left, okay, which one is the short leg? Is it X? It's half of X. Which one is the longer leg? The 12 is the longer leg because the Y is the hypotenuse, okay? Huh? Okay, so this one here is only half X. Okay? All right. So, what I'm given is this. So if the long leg is 12, how much is the short leg? Let's see. The long leg is root 3 times the short leg, right? Is that true? So 12 is root 3 times the short leg. So how much is the short leg? Right, but in this case, divide by root 3, divide by root 3, 12 over root 3. Does that make sense? Or no? Okay.
Well, it makes sense, but that's not possible.
Oh, no, it's fine. We're going to get rid of the root.
Yeah, you multiply it to the next root of 30 and divide by 2 to get to the short.
Yeah. Okay. So, take a look here. Take a look here. We need to find this side. Okay? That's the short leg. How do I find the short leg? Look at this one. This is what we know, correct? So let's solve this for the short leg. How much is the short leg? Can we say it's the long leg divided by root 3? Yes, is everybody okay with that? The long leg divided by root 3. So that is 12 over root 3. Now, you rationalize the denominator, so that's 12 root 3 over 4. Over 3. This is 4 root 3. Oh my gosh. So that's the short leg. That's 4 root 3 over here. So how much is x? X is 2 times 4 root 3, 8 root 3. Okay. Now, y is the hypotenuse. The hypotenuse is also 2 times this, right? But also, look at this. This entire thing was an equilateral triangle. So whatever this side is, that's also the same. So that's also 8 root 3. Okay. Let's do the next one. Okay. The perimeter of an equilateral triangle is 18. Find the length of the altitude of the triangle. All right, well, if the perimeter is 18, each of the sides is how much? 6. All right, and we need to find the altitude. So this is what I need to find. So immediately, you know that if it's an equilateral triangle, this is 60, that's 30, and that's 90. That's the first thing you need to do. And now we need to find this h. Okay? So, if the whole bottom is 6, then this is half of it, which is 3. So now, that's the short leg. This h is the long leg. So h is the short leg times root 3, 3 root 3. Okay? All right. Next, the diagonal of a square is 10 centimeters. Okay, a little bit of advice. Whenever you have ones like these, always draw the diagrams. Okay? So the diagonal is 10 centimeters. Find the perimeter of the square. Okay, so if this is a square, all of the sides are equal to each other. So this is 90 degrees. How much are each of these angles? 45, because it's an isosceles right triangle. Okay, so what do we know about the leg in a 45, 45, 90 triangle in reference to the hypotenuse? Leg is how much?
Hypotenuse over square root.
Hypotenuse over root 2. So multiply by root 2. 10 root 2 over 5. I'm sorry, over 2. So 5 root 2. Okay? So that's just one side. And how much is the perimeter then? 4 times 5 root 2, 20 root 2. Okay. Next one. Okay, so the next one, I'm going to have you do it on your own. I'm going to give you about like 2 to 3 minutes, and I'm going to have you do it on your own. The length of an altitude is 5 root 2. Find the length of each side, and then find the area. Okay, when it says use exact answers, that means no decimals. Either roots or fractions or whatever. Simplified though. Okay, all right, so it says the length of the altitude is 5 root 2. So first we draw that, and we write down that this is 5 root 2. Now, this is an equilateral triangle. So each of these angles are 60. So I have 60, 60, and how much are each of these? 30, 30. Okay. When you do that, all right, you're going to basically split your triangle into two right triangles, and then you're only going to focus on one of the right triangles. So just pick left or right, okay? Now, what do we need to find? We need to find the length of each side. Okay, so I'm just going to pick this triangle right now to the right, okay? Just this one. Now, I'm going to call this side x and this side y, and then the vertical one is 5 root 2. So between these three sides, which one is the long leg? 5 root 2. Which one is the hypotenuse? So the short leg is x, okay? Now, the long leg is the short leg times root 3, okay? So take a look here. The long leg is the short leg times root 3. So that means, look at how I do this. I say it out loud to myself. Okay, on the test, you can't say it out loud to yourself, but you can say it in your mind. Here it is. The long leg is equal to the short leg times root 3. Yeah. Now what are we going to do? Now we're going to divide by root 3, divide by root 3. These are so much fun. Okay, so x is 5 root 2 over root 3. But now what do I need to do? Get rid of the root 3. So root 3, x is 5. Okay, on top I have root 2 times root 3. That gives me a root 6 over 3. Okay, so x is 5 root 6 over 3. Okay, now, okay, so now, okay, this side, y, that's the hypotenuse, okay? The hypotenuse is the short times 2. The way I would write it, okay, the way I would do it is, in my mind, I say hypotenuse, which is y, is the short leg times 2. Well, in this case, this is 2 over 1. So this is 2 times 5, 10 root 6 over 3. Okay? Now, if this is 10 root 6, that y over there, 10 root 6 over 3, then this is also 10 root 6 over 3. And how much is this entire side? 10 root 6 over 3. So now let's find area. Area is half times base times height. So this is half times the base is this entire side, 10 root 6 over 3. The height is 5 root 2. So do you see what I'm doing here? I'm compartmentalizing. I'm only taking one element at a time. Because if I think about the whole thing at a time, then it's overwhelming and confusing and very, very frustrating. All right? So here we go. So now let's see what we can do here. This 2 can reduce with this 10 and become a 5. So area is, okay, this is over 1. In the numerator, I have 5 times 5, 25 root 12 over 3. Okay. I'm like this close to being done. Now I need to ask myself, is there anything else to do to reduce this? Can I reduce the 25 and the 3? How about the root 12?
Yes.
Okay, so let's see. 12 is 2 times 6, which is 2 times 3. Oh, a 2 comes out and a 3 stays in. So this here, let's see, 25. What was root 12? 2 root 3 over 3. This is 50 root 3 over 3. Whew. Man, that was a workout, right? Yes.